this module, you will learn about equilibrium in chemical processes and its characteristic features. Equilibrium in chemical processes, called chemical equilibrium, is the most important characteristic of irreversible reactions. The characteristics of chemical equilibrium can be understood only when you are familiar with certain terms, like reversible reactions and forward and backward reactions. So, let's get acquainted with these terms first. In general, the transformation of one substance into another is known as a chemical reaction. The chemical substances used at the initial stage during such transformation are called reactants, and the final chemical substances formed as a result of the chemical reaction are known as products. A reversible reaction may be defined as a chemical change in which the products can be converted back into the original reactants under suitable conditions. In a reversible reaction, the reaction in which the reactants react to give the products is called the forward reaction, while the reaction in which the products react back to give the reactants is called the backward reaction. Depending on the chemical nature of the products and the reaction conditions, the products formed may or may not react to give the initial substances. Let's take the example of the decomposition of calcium carbonate to demonstrate a reversible reaction. When calcium carbonate is heated strongly, it decomposes to form calcium oxide and carbon dioxide gas. When this decomposition is carried out in an open vessel, carbon dioxide, being a gas, escapes. Hence, there is no possibility for the products calcium oxide and carbon dioxide to react and give back the reactant calcium carbonate. Thus, the reaction proceeds in the forward direction only. Thus, the reactions whose products cannot be converted back into the reactants are known as irreversible reactions. When the same reaction of the decomposition of calcium carbonate is carried out in a closed vessel, the products, calcium oxide and carbon dioxide, combine to give solid calcium carbonate back. This clearly indicates that the reaction is capable of occurring in both the forward and the backward directions under favorable conditions. Such a reaction is called a reversible reaction. Reversible reactions are represented by a pair of half-headed arrows. If we plot a graph of a reversible reaction, we will notice that the rate of forward reaction is initially high. With the passage of time, the reactants deplete and the products accumulate. This leads to a decrease in the rate of the forward reaction and an increase in the rate of the backward reaction. After some time, a stage is reached when the rates of both the forward and the backward reactions becomes equal and the system reaches a state of equilibrium. We can graphically represent dynamic or chemical equilibrium as a forward reaction starting at a higher rate and a reverse process starting at zero rate coming together to reach an equilibrium point. Hence, when a reversible reaction is carried out in a closed vessel, a state is reached when the rate of the forward reaction becomes equal to the rate of the backward reaction. This stage is known as chemical equilibrium. It must be noted that the reaction can reach a state of equilibrium even if we start with the products, which is because equilibrium can be reached from either direction. The dynamic nature of chemical equilibrium can be understood by studying a gas phase chemical reaction. For example, when hydrogen and iodine are heated in a closed vessel, they react to form hydrogen iodide. When a mixture of equal initial concentrations of hydrogen and iodine are taken in a flask, maintained at 717 Kelvin, the intensity of the purple color decreases after some time. This is because, as the reaction proceeds, the concentrations of hydrogen and iodine decreases as they are consumed, and hence the rate of forward reaction slows down. On the other hand, the concentration of hydrogen iodide increases with the progress of the reaction. As hydrogen iodide accumulates, the backward reaction of hydrogen iodide decomposing to hydrogen and iodine becomes significant. A stage is reached when the rates of the forward and backward reactions become equal, and the system is said to have attained equilibrium. At equilibrium, the concentrations of all the three species become constant. The graph depicts the variations of the concentrations of hydrogen, iodine, and hydrogen iodide as a function of time. You have already learned that in a reversible reaction, the reaction can reach a state of equilibrium even if we start with the products. Hence, the same state of equilibrium can be reached even if we start with hydrogen iodide alone. In this case, the concentration of hydrogen iodide will decrease and the concentrations of hydrogen and iodine will increase until they become constant at equilibrium. The attainment of equilibrium from either side can be shown in the form of a graph. The dynamic nature of the chemical equilibrium can be established by using radioactive iodine. When a small quantity of radioactive iodine is introduced into the above reaction in the state of equilibrium, it is found that the hydrogen iodide in the mixture contains radioactive iodine. This obviously shows that the reaction, though apparently standstill, is proceeding in both the directions. That is, the equilibrium is a dynamic equilibrium. Hence, the characteristics of chemical equilibrium are: equilibrium state can be approached from both the sides. The equilibrium is a dynamic equilibrium as both the forward and the backward reactions continue to take place with the same speed. At equilibrium state, properties such as pressure, concentration, density, or color remain unchanged over time. Equilibrium is possible only in a closed system. You have now reached the end of this module. In this module, you learned that the reactions whose products cannot be converted back into the reactants under any conditions are known as irreversible reactions. The reactions whose products, under suitable conditions, can be converted back into the reactants are known as reversible reaction. Reversible reactions are represented by a pair of half-headed arrows. In reversible reactions, the reaction in which the reactants react to give the product is called the forward reaction, and the reaction in which the products react back to give the reactants is called the backward reaction. When a reversible reaction is carried out in a closed vessel, a state is reached when the rate of the forward reaction becomes equal to the rate of the backward reaction. This stage is known as chemical equilibrium. Equilibrium state can be approached from both the sides. The equilibrium is a dynamic equilibrium as both the forward and backward reactions continue to take place with the same speed. At equilibrium state, properties such as pressure, concentration, density, or color remain unchanged over time. Equilibrium is possible only in a closed system.